Hello everyone and welcome to our next episode of our SpatialAnalyzer technical webinar series. Today we're going to be talking about how to use our inspection toolbar and the new feature SmartFeatures to achieve some basic level automation. First I would like to introduce myself. My name is Anna Smith. I'm a SpatialAnalyzer application engineer based out of Jacksonville, Florida. So if you are a customer located in the southeast region of the US, if you ever get a support visit from SpatialAnalyzer, odds are it will probably be myself or one of our other application engineers. So hopefully I'll get to meet a lot of you in the future. Before we get started on our specific topic, I do want to point out a couple things. I am on our website, kinematics.com, right now. And a few things I want to note is our download page up here in the right-hand corner. If you select that, it will ask you to enter your own information. Mine's defaulted, Anna@Kinematics. That's also my email address if you ever need to reach out with any questions. You'll submit your information, and then this is where you're going to be able to download our latest release of SpatialAnalyzer as well as our latest beta. The reason I want to make a specific note of that today is I will be using our latest beta in this demonstration, and that is because SmartFeature is a new feature. You will see it on our next upcoming release of SA. Hopefully that will be coming very shortly, but right now it is only available in our beta. It's not available in that latest full release, that 720 release. So if you do want to play around with SmartFeatures before that next full release, come get our beta version here. Another note I want to make is if you do run into questions as you're starting up with some basic level automation or any other questions you come up with while you're on a job, we have our technical support line here. So you can always email or call me with questions, as well as our support@kinematics.com email. And we do have a support line, the 757-565-1500. So you can contact us either way to give us your support questions, and we will get back to you within 24 hours on those questions. One other note I do want to make while we're here is this SA community page. As you're getting to know SA or starting any new jobs and you're in some unfamiliar territory regarding SpatialAnalyzer, if you think you're having a question that maybe somebody else probably asked at one point, the SA community is a great place to go. It's a great resource for learning new things and just getting to know SA or new topics within SA a little bit deeper. We do have it divided in all of these different sections. So let's say if you do get a new instrument, you can go to supported instruments, and we have quick start guides for each of our instruments on how to get connected to SA. Or if you have specific questions on utilizing CAD or creating relationships. Another note is that our YouTube channel is a great resource to go as well, and these are articles on the community page. Our YouTube channel will have a lot of videos ranging between 2 minutes to 30 minutes, depending upon the topic. That is also a wonderful place to go to get to know SA and answer any of your questions. And then these technical webinars will also be recorded and placed on our YouTube channel once they are completed. So if you want to rewatch this webinar, you can access that on the YouTube channel after it's done recording. All right, so let's go ahead and get started on our topic-specific stuff. So I'm going to give you one moment. I'm going to switch over to SA here. Get rid of my little photo there. All right, so this is the part I will be inspecting and using throughout the webinar today. Just in case you haven't seen it before, this is our SA demo part. So we have two surfaces here, our vertical piece and our base plane with a few bores and a bolt hole pattern cut out there, and then this cutout here will fit to a cylinder. We'll look at that. My first few topics I won't be utilizing CAD, so I did just want to make you aware of what we'll be measuring and what that looks like. So I'm just going to go ahead and delete those surfaces now, since we won't be needing those as we get started. So when you open up SA, this is going to be an empty file, a new file. You have your collection and your world frame. What we're going to be talking about at first is the inspection bar and just what that is. So if you used to use Toolkit, before you switched over to these ribbon bars, if you're missing that toolkit feel, you can have an inspection bar over here on the right-hand side like you would have seen with toolkit, and that's if you go to your home tab and over here, inspection bar, it'll pop it up right there. It even still has that toolkit name for you. So this is going to help you create your inspection a to-do list, essentially, on what you want to inspect. If you don't want this inspection bar over taking up the right-hand side of your screen, and you want to save a little bit of screen real estate for your graphics, we can put it down here as well. So if we right-click in this space next to our SA tree bar, how you would also bring up your report bar, underneath that you have inspection bar. And so that'll pop up our inspection bar just here, and then you can drag it by hovering over that seam, drag it up if you'd like it to take up most of the room, or down if you want to see more of your tree there. So this is going to serve as essentially our inspection to-do list. Just as a quick example, before we get into smart features, if we want to say we want to measure a couple planes and a circle, we can add that to our to-do list over here, just having features. If we select plane, another plane, and a circle, those add it to our inspection to-do list. Let's go ahead and talk about smart features next. So this is very exciting stuff. This is, again, only on our beta version right now. It will be in our next full release. We go ahead and delete these relationships out. Give us a clean, empty file once more. And then smart feature is this little light bulb right here. So it's going to auto-detect what you're measuring. If you hit the drop-down, you have configure auto-detect feature settings. You only have two settings to adjust here. It's your auto-fit tolerance. So what that is when you start taking points, once you accept it and say, hey, I'm done taking points for this feature, it will then run through and try to fit geometry to that data set, and then once it finds a geometry shape that fits within that tolerance, so right now the default is 10 thousandths, it will fit that geometry and save that as your feature. And then this auto reset projection plane checkbox, that's telling us that if we measure a plane and it auto detects a plane, that plane will then become our projection plane for features measured from that point on. And then once you measure another plane, the second plane will then become your projection plane for features, any features measured from that point on. One thing I do want to note for that auto reset projection plane, if you're trying to switch between two projection planes and you measure your first plane, take some features, and then you want to switch that projection plane and measure a second plane, if that second plane is perfectly orthogonal to your first plane, right, perpendicular, it'll fit that as a line and project that down. So the best way to go through that is to measure a second plane that is not perfectly orthogonal to your original plane. So just a little tip there. Let's get started and start using our auto detect features here. To do that, I will need an instrument in my file, right, because I need to start taking measurements. So let's add my instrument. Go to my instrument tab, selecting add. This is the arm I'll be using. It is saved under my instruments. It's the hexagon absolute arm. I'll add that in. That is now in my file. Let's go ahead and get that connected. All right, and I'll just be probing right now. We will play around with the scanner here in a little bit. But for smart features right now, let's just stick with the probing. And I'm going to go ahead and I'm going to leave my default as 10 thousandths. That has been working for me fairly well. I haven't had to adjust that at all. So let's go ahead and select auto detect. I'm going to start taking some measurements. So on that SA demo part, I'm going to take measurements on that base plane, so that blue plane we saw earlier. Let's do a couple of points here. And then to toggle on my arm, I'm sliding my trigger to the right to accept it. So right now it still says auto detect. Once I accept it, it's going to run some calculations and it fit a plane there. So do you see that now? Now it's listed as a plane. And that's automatically setting my projection plane up here. So that base plane is now my projection plane for any features I measure from this point on until I measure a new plane. Alright, so now I'm going to measure my main bore. We should get a circle from this. Once I accept that, it fit a circle, and there we go. We can see it projected right onto that plane. Let's get our bolt hole pattern, and so let's see if we can call it bolt hole, and start with our auto detect. And we can just continue on, and it should toggle through those names, and it's fitting circles to those. Then one more. All right. And then let's go ahead and remove that name. If we want to measure our vertical plane, since it is perfectly orthogonal, I'm just going to manually remove that projection plane, and we should be able to measure a new one. Once I accept that, and it fit that as a plane, so we now have our vertical plane. Oh, pardon me, I messed up my naming there a little bit. You can adjust names in those relationships. I can show you that too, because I'm sure I'm not the only one that's misnamed an object before. So let's go ahead and get that cylindrical cutout as well. Just taking a bunch of points up here. We've got that cut out. And one thing I do want to note is sometimes if your tolerance might have been a little bit too tight and it doesn't recognize it, I'm going to do another one just remeasuring that main bore, but I'm going to let my hand slip a little bit, kind of intentionally, just to also, if your hand slipped in the measurement and you have a little bit of a rogue point, I'll try to accept that. And it didn't find geometry that fit it, so you just see that little dot there. It didn't fit a geometry relationship. I'm going to stop trapping right now. So you can assign, we can go ahead, I see my point where it slipped right there. That's that blue point. If I wanted to go delete that one, and now I know I want to fit a circle, I can do so. If I right click and there's a resolve auto detect feature geometry, you can, if you want to rerun the auto, we can, or you can force it with circle, cylinder, and so on. There we go. We fit another circle. So that is utilizing our SmartFeature to pull geometry, and without you having to tell SA what you're measuring ahead of time. That can be very nice if you're just measuring a lot of pieces of this part and don't want to go and create your template ahead of time or tell SA what you'll be measuring. If you wanted to use this tool to create a template, you could. So let's say that was my measurement process using those that auto detect feature. I'm going to use this to create a template. I could then, let's say this part is serial number 1, and I want to measure my second part, serial number 2, but it's the same kind of part. I could save this file as SA demo part serial number 1, and then I can, if I go home, there's this clear data. I can delete all associated data. And it's going to delete my points, but it's going to leave these relationships. This auto detect was the last one. There aren't any points in there. So delete that guy. So now I have a full inspection plan with my little checklist of those features I want to measure. And if I wanted to start measuring serial number 2, I could just double click on this plane. It's ready for me to start taking points there. And then I can just accept through, continue measuring through that little inspection to-do list. All right, so that is using or how to utilize SmartFeatures. I'm going to open up a new file so we can start using our inspection bar without any CAD. So to do that, I'm just going to come up here, hit new. Not going to worry about saving this. We're just kind of walking through the steps here. All right, so now if I wanted to create an inspection plan without any CAD though, so I'm going to be, again, using my essay demo part. Let's create our inspection to-do list. So in my features, let's say I know I'm going to measure my vertical plane. And this is something if I'm going out on a job, if I want to sit at my desk in the air conditioning in the summertime, I can create this whole inspection plan there and then go out to the shop floor, make my measurements, and it'll all be good to go from there. So this can all be done as desk work ahead of time. So if I want to do my vertical, and I know that's a plane, let's call my next one base. I know that's also a plane. Let's get my cutout, which is a cylinder. Let's get my main bore as a cylinder as well. And then let's get my bolt holes, that little 4 bolt hole pattern. PH1. I am going to set my base plane. I'm going to get circles for these. So I'm going to set my base plane as my projection plane. And I can do this ahead of time even though I haven't gotten a measured plane yet. So I can just go into that relationships, double click on that plane within it. And now geometry relationship base is going to be my projection plane for bolt hole 1. I can just hit circle. Keep hitting it and it'll auto increment through those 4 bolt holes. If this was a full inspection and let's say what I'm looking for is the linear dimensions between each of those bolt holes, I can go ahead and set that up ahead of time as well. So I can go under reporting, under dimensions here, hit this little double down arrow drop down, object to object linear dimensions. I can come here between my circles. I'm going to go between bolt hole 1 and bolt hole 2, and then 2 and 3, 3 and 4, and then between 4 and 1 to complete that circle there. Maybe I want the angle between my vertical and my base. So let's go here between my 2 planes, between my vertical and my base. So now in my tree, I can come down and I have dimensions already set up. They're all grayed out because there's no data yet, but this could be a full template right here. I have my relationships set up, my little inspection to-do list here telling me what I need inspected, and my dimensions already pulled out. So let's go ahead and add my instrument and start taking these measurements. Go ahead and add it. Again, it's the same arm. Let's get connected. All right, so then to tell my arm what I'll be measuring and to start this to-do list, I just double click on vertical. And then this little yellow box with a green arrow, you can see it in this inspection bar as well as in my tree. It's telling me it's ready for my measurements to be trapped into that vertical relationship. So I grab my arm. And it's just looking for 4 measurements here. That's the default I have for a plane. And once I got those 4, it auto toggles to the base. So now I'm taking the points on my base plane. I'm now going to the cutout, so that cylinder in that vertical. Taking a bunch of points there. And here I'm going to slide the trigger on my arm handle to the right to accept that. Here, sorry, I'll zoom in the graphics here so we can see these a little bit better. So now we can see we have a dimension here for that angle between the base and vertical because we've gotten that data already. So now onto the main bore, which is also a cylinder, but it's cut out into that base piece. I'm going to accept that. Then onto the bolt hole. So we can see that main bore there, and then these bolt holes should show up right around here. And they should be circles projected up to that base plane. And we can see those dimensions starting to pop up. as I measure each of these bolt holes. We accept that, and we've gotten all of our measurements. So we've pulled dimensions there. We've gotten the distances between the centers of each of those holes and the angle there. If we wanted to clean that up a little bit, we could shrink the text size of those dimensions down really quick. If I go into one of the properties, let's shrink it down until it gets into the middle there. So that's kind of what I prefer, seeing it between those two holes. And I can just apply that to my selected dimensions. There we go. And that shrunk those down there. And then from here you can just run a quick report, generate that, and we have our report with everything in it. So that was a super quick little part inspection. We pulled the dimensions on those bolt holes and the angle between these two planes. And then from here, if let's say, again, that was serial number 1, if we wanted to clear that out, save it as a demo part, serial number 1. And then you could just come in here, come to the Home tab, clear data, delete all associated data. And there we go. Now we have a cleared out inspection to-do list there. So we could then go ahead, double click on our vertical and start remeasuring the next part. So we can go through from part to part incredibly quickly there. Let's continue on. So that was doing utilizing the inspection bar without any CAD. Let's go ahead and try it with some CAD, bring some stuff in. Again, I'm just going to open up our new file so we have a clean slate there. So here I'm going to be inspecting the same part, of course, except let's bring in the CAD this time. So to bring in that CAD, I just have it saved under my CAD files. It's my SA demo part in inches, dragging it and dropping it into the graphics view there. All I want here is the surfaces, so I unchecked everything else and then rechecking the surfaces here. I can see that I'm bringing in 2 surfaces from this legend over here. If I hit OK, it'll bring that in. It's coming in as wireframe. Let's make it solid so we can see that. All right, so that is what I'm looking at. Let's go ahead and bring in my instrument so we have something to measure it with. Adding my instrument, let's go ahead and get connected. All right, so with CAD, we can let's set up a similar inspection plan, but we're gonna pull our nominals from our CAD, so we'll have nominals this time. So if we go back into features, we have this handy dandy CAD button right here. Let's still give it some names. So we can keep our head on straight. Let's call it vertical from CAD. And that's then pulled that vertical plane right there. I'm going to bring in base. Pull my base and see we're creating these relationships here. Let's get our main cutout. Pull that cylinder. Let's pull our main bore as a cylinder as well. And then let's again pull our bolt holes as circles and have those projected up to our base plane. So we're going to select our plane to project again. We're coming into our measured base. So we have a nominal and a measured now, but since we're we're getting our measured data, we want to project to our measured base. So select that. Oops, and here we go. I misnamed things again. So let's call it bolt hole 1. Well, if I could type. And delete. Oh, I know. I'm going to keep that guy. Bolt hole 1, setting our GR base. And then here we're going to be going from CAD 2D geometry. Bolt hole 1. 2, 3, and 4. All right, and then again, let's go ahead and we could set up some dimensions. For time's sake here, we're going to skip that. We went through those steps already. So right now it's ready to trap to these data just one at a time. If we hover over this right-hand arrow, we see this right click is selected multi-feature scan. So what that means is we can scan into each of those features at once, and it's going to use proximity to assign data to each of those features. But since it's using proximity, what we have to do first is get our instrument aligned to our part. So let's run through a quick align before we go through our multi-feature scan. So I'm going to stop trapping by hitting that red box. Then if we go into alignment, let's just do a quick align. It's asking me what instruments would I like to move. I'm going to move this instrument and hit enter. I'm not moving any objects. I'm going to move my instrument to my objects. So I'm just going to hit enter here, and I'm going to select 6 inspection points. So I'm going to choose 3 on this base, 2 on the vertical, and then 1 more on this side to lock it in all of the degrees of freedom, and hit enter. It's then going to walk me through the quick align process and what points I should hit, and give me little targets. So I'm going to get that point. And then as I'm taking data, it will be running that alignment. And then lastly, this one on the side. All right, it should be roughly aligned here. I'm just going to accept that. If I want to double check, make sure I'm fairly well aligned, I can add a watch window to my CAD. Then if I put my probe tip down on my CAD, we can see we're anywhere from 1 thou to 8 thou. My part is tacky taped down to my dining table at home and the arm is clamped down, so I'm not expecting too crazy stability here. So I'm going to call that acceptable on my quick align. So now I'm roughly aligned, so I can use proximity to assign my data points to each of these features. So let's start that. Let's right click here on that arrow. Once I do, it's going to ask me which relationships I want to be trapping to. Since this is the first go, I want to just trap to all of them. And hit OK. So now you can see they're all yellow and with the green arrow saying it's ready to accept data. So I'm going to switch my arm over to scanning. There we go. And start bringing in some data. Oh, here, let's make this wireframe again so we can see a little bit better the data coming in. Alright, I'm going to try to get good coverage on each of these planes. Then I'm especially going to take some time trying to get into the center of all of those holes to get onto the wall so it can construct the cylinder for that main bore, as well as get additional data for each of those bolt holes. And this is a fairly small part with some small holes, so we'll see how good it gets here. How well I can do on collecting all of that scan data. I'm going to get the vertical plane as well. Is that cylindrical cutout there. I'm going to hit each of these bolt holes again. Give it a good chance at collecting that data. Alright, let's see how that goes. I'm going to accept that. I'm going to hit stop trapping. It's then going to go and calculate each of those using proximity to fit each of those relationships. So it looks good. It looks like, I got all of them except for bolt hole 3, and then it looks like my main bore, it just didn't have enough data there. It only picked up a few points on that wall. That is my fault. I did not get enough coverage there. And then this one, it looks like as well, it fit a cylinder, but it's a little bit off from nominal. We could do a little bit better there. If we wanted to add some additional points, say this is good, I got a good fit on the majority of them, but I want to add some to this main bore, I can then just double click, ready to collect some more data. I'm going to switch over to probing because I can get in there a little bit better on these small holes with that probe tip. Make sure I'm getting good coverage. Now I'm just adding a little bit of data to that relationship. And there we go. That's a much better fit there. Hit stop. There we go. And if I want to take a look at the nominals there, if I right click and open up my report bar and select my main bore, we can see I have a nominal and a measured, and that's looking pretty good. We have a 2 thou delta there on that diameter. And then let's see on this cutout, got a pretty big difference there, a deviation. If we wanted to add some more data, we can just double click on it. It's ready for some more data to be tracked. I can take some additional data there. Oh, my hand slipped off for a second. Let's see how that goes. Stop trapping. All right, definite improvement. We've got a 40 thou delta there on deviation, but like I said, I did feel my hand slip there. So again, we can blame me on that one. So that is utilizing the multi-feature scanning, which can definitely speed up an inspection process. All you have to do is have those features set in your inspection bar, and you can get that from your template, and then quick align your instrument to your CAD file, and then go ahead and scan into each of those at one time. I am running over here, but I do want to mention measurement plans really quick, because that's going to be a higher level automation technique that SA provides. So we're not going to get too much into the details here, but I just want to make sure you all are aware of it. To view MPs at first, you'll see it in the scripting tab is where you're going to be able to write and edit MPs. Let's open a help file just to see what they do. We go to help, sample files, and then we open up MP analysis demo. This is just a sample file, so you'll see this little window pop up. Just hit OK. In this file, it's a simple file. You can see we have one point group, a CAD surface, and then a measurement plan over here in our tree. To see what this MP is going to do, we can right click and hit edit. That'll bring it up. It's only 7 lines of an MP. You can add lines and add commands by searching in here and then adding them. So this MP is going to set the render mode. It's going to make groups to object relationship. If you expand that, you can see where you'll select your group and your object. You're creating this relationship between in those arguments. And then some other settings there. We'll do a relationship fit. We'll set some colorization options, set point of view, we'll construct vector groups, and generate a quick report. So we're going to essentially do a full analysis after we've collected that data with just 7 lines of an MP. So to run that, I didn't change anything, so I'm not going to worry about saving it. To run this MP, I just double click on it. It set that render mode, created the relationship, did the fit, created the vectors, and generated that report in just a couple of seconds. So writing MPs, if you want to really get in depth with it, we do offer a 3-day MP class. If you're wanting to get into some basic MP work, feel free to reach out to our support line. I would highly recommend going into these sample files and just kind of viewing the MPs, right-clicking and seeing edit, seeing what those steps look like. Some other sample files, we have MP scripts up here. So this will have, these are all different MPs and each of them do something different. So take a look at those and the steps within there and see what all MPs are capable of. They can do a lot. I will note that you do have to have an ultimate license to use MPs, but they are a fantastic tool. And oh, one last note, because this is also pretty cool with MPs. You can add them to your inspection bar. So I'm just going to open up the sample file again so we have a clean one without it having been performed yet. All right, so here we have the beginning of the file already. Just for argument's sake, let's say you wanted to measure a couple planes and then you wanted to run this MP. You can add the MP as a little to-do list item in your inspection bar by going in your Features tab, going under Special, and adding an Inspection MP Execution node. So that adds a little MP Execution node there. If you right-click on it, and go under inspection, you can connect an associated MP. So if I click on that, I'm going to select my analysis MP, hit OK. That's now associated with it. If I toggle through these, it's then going to run that MP once it gets to that step. So another great thing to do and to utilize MPs for. They can be as big or as simple as you'd like. Sorry, we did run a few minutes over, but hopefully this was helpful. It's a really quick introduction into some basic automation within SA. If you do have questions, please reach out. And this webinar is being recorded, and it will be available on our YouTube channel if you'd like to rewatch it later or share it with one of your colleagues. Thank you guys so much. That is all I have.